Hey guys, apologize for the wait. This is going to be your final review. I did this earlier, but the computer was lagging so much it lagged the recording, and thus you couldn't understand anything. So this is my second time doing that. With that in mind, I'm just going to show the setup for anything you have to answer. So anything here in the review packet where you could look at the answer, look at the answer. I'm just doing the setup or explaining how to get to the answer. But I'm not spending my time with the math, hopefully to make this video a little shorter. All right, first off, the first section of our test is trig, reminder of SOHCAHTOA. So let's just use that to our advantage. So SOHCAHTOA. SOHCAHTOA, just as a reminder, so means opposite over hypotenuse. Ka means adjacent over hypotenuse. And TOA is opposite over adjacent. Reminder, what is opposite, adjacent, and all that? If your theta's down here, that means this one over here is the opposite because it's across from the theta. This one right here is the adjacent, and this one is always the hypotenuse, and we know it's the hypotenuse because it's across the right angle. So if something like this, if I say sine of W, I'm putting my theta at W. Sine is opposite over hypotenuse. So the opposite is 24 over the hypotenuse, which is 30, which we can simplify to 4 over 5. If I said cosine W is going to be adjacent, which is 18, over hypotenuse, which is 30, or 3 over 5. Remember, these are going to be like a multiple choice question, so they'll already be simplified. So you might get 18 over 30. You're like, well, that's not one of the answers for centoval. Remember to simplify the fractions. Tan W is opposite over adjacent. So that's going to be 24 over 18. If I do it at some other point, like at x, then I base it off my x value. So my sine in this case is going to be opposite 18 over 30. So it really matters what angle you're coming from, okay? So for this one, we're solving for x. So in order to do that, we're going to set up here. I have an angle right here, and this is my opposite, and this is my hypotenuse. So because this is my opposite and this is my hypotenuse, I'm going to do so, or sine. So sine of 31 equals opposite x over hypotenuse 15. In this case, what I would do is multiply 15 on both sides to get rid of to get the x by itself. And then I would type into my calculator 15 times sine 31. Make sure your calculator is in degrees. During the final, I'm happy to walk around and check if that for you. But it's going to be 15 times sine 31. You typed in a calculator, you'll get some answer. So this one, kind of same thing. This is a tangent. So we're standing here. This is opposite. This is adjacent. So TOA tells me I'm going to go tangent. So tangent of 48 equals TOA opposite x over adjacent 7. Same situation, times 7 on both sides. That will be your answer when you type it in. Over here, this is 68. So in this situation, I have adjacent and hypotenuse. This is cosine. So cosine, because I have adjacent and hypotenuse, 68 equals 22 over x. So in this scenario, though, x is on the bottom. So I multiply x over here, and I'm going to divide cosine 68 over here, divide cosine 68 over here. Because I want my x to be not only by itself, but on the top of a fraction. I don't want it to be by itself on the bottom of a fraction. So it ends up equaling x is 22 over cosine 68. And then you type it in your calculator, you get your answer. Same thing here. This is opposite hypotenuse, so the sine 39 equals opposite 11 over x. If x is on the bottom, I could just swap the positions. So x equals 11 over sine 39. You could technically do that with any equation that equals a fraction. You can always swap the bottom and the top with each other. Okay. This one, because it is, I have two sides and I'm missing the angle. In this case, I have adjacent and opposite, so that's tangent. I'm going to do tangent of x equals opposite, 28, over adjacent, 19. So in this scenario, I want tan by itself. So I'm going to get rid of tan, or I want x by itself. And the best way to get rid of x is by using its anti-trig, or the inverse trig. So we're going to use tan negative 1. You might also hear it as arctan. Tan and tan negative 1 cross each other out. So it's going to be x equals tan negative 1, 28 out of 19. So it's going to be something like that. And then you type that into your calculator. It's the same thing here and here, where you're going to use the negative 1 to set up your thing. So the setup for this one, this is opposite hypotenuse. You're going to get sine negative 1 of opposite 5 over the hypotenuse 16. Okay. And this one, this is adjacent hypotenuse. So that's cosine. So cosine negative 1 of adjacent 24 over hypotenuse 28. All right. The angle of elevation from a buoy in the water is at the top of the lighthouse at 68 degrees. So when I say elevation, I'm looking up. So the buoy is looking up at the lighthouse. And here's our right lighthouse. And here's my buoy. So it's looking up at 68 degrees. If the buoy is 300 feet away, so it's 300 feet away from the base of the lighthouse, so from ground to ground, what's the height of the lighthouse? So once I draw it out like this, I realize it's just a right triangle, where it's going to be opposite over adjacent. So this is a tan situation. So tan of 68 equals opposite x over adjacent 300 times 300 on both sides. 300 times tan 68. Whatever that is your answer. A wire is tied from the top of one tower to another tower. So tower A, tower B. The angle of depression, so we're looking down now. The angle of depression from the taller tower to the shorter tower is 37 degrees. So since I'm looking, it's depression, just think you're depressed, you're a little sad, you're looking down. So it's downwards. Versus elevation, I'm looking upwards. If the wire is 100 feet long, so if the wire is 100 feet long, this is a wire that's 100 feet long, find the distance between the two towers. So if the wire is 100 feet long, I need to figure out how long this is, aka the opposite. So in this case, this is the opposite. This is the hypotenuse. I have an angle there. It's going to be sine. So sine 37 equals opposite over hypotenuse 100 times sine 37. All right. Chapter 8 is polygons. So let's go through polygons. Reminder, if you want the sum of all interior angles, it's 180 times n minus 2. The sum of the exterior angles, no matter if it's 3-sided or 300-sided, it is 360. It's basically the leftover two 180s that are on the outside. Each exterior angle, if I want a regular polygon, remember regular means all the same size, that's 180, n minus 2, divided by n, because I'm dividing by how many sides I have. So if it's a 6-sided shape, I divide it by 6. And here's each exterior angle. Since it's a regular polygon, it's always going to be 360 divided by how many sides I have. So if this one, I want to find the sum of the interior 25-sided polygon, I'm going to do 180 times 25 minus 2, or 180 times 23. Again, check your answers at the back. I'm just doing the setup so I can finish this in a reasonable time. This one, the sum of the measure of the interior angles is the polygon is 1620. So since I already know the answer, I know the solution is 1620, and I'm just going to set it up to the equation which is 180, n minus 2. So the better way to do this, you can distribute and then do the work, but you could just divide both sides by 180 first. And then that's going to be 9 equals n minus 2. I mean, I'll finish it off. Plus 2 on both sides. 11 equals n. All right. What is the measure of each interior angle of a regular pentagon? Remember, regular means all the sides and angles are the same. So in this situation, I'm going to do 180 times 15 minus 2 divided by 15, which simplified is 180, 13 over 15. That's some number. Use your calculator. What's the measure of each exterior angle of a regular hexagon? A hexagon is 6-sided. So its exterior angles. So 300 divided by n, in this case, is 6. So 360 divided by 6 happens to be 60 degrees each. If an interior angle of a regular polygon measures at 140, how many sides does it have? So since I know each angle of a regular polygon is 140, the interior angle is 140, I can set it up as 140 equals 180 n minus 2 over n. The best move here is to multiply n on both sides to get rid of the n on the bottom and distribute the 180. So I end up getting 140n equals 180n minus 360. A little bit of algebra, negative 40n equals negative 360, n equals 9. Over here, if the exterior angle of a regular polygon measures 15, how many sides does it have? So it's the exterior angle of a regular polygon. So I know 15 equals 360 divided by n. Reminder, when you have an exponent in the, or a variable on the bottom, you could swap it to what it's equal to. If it was a fraction, you could swap it to what's on top. So it's going to be 360 divided by 15, whatever that is, 24 I'm thinking, but check that, I don't know. All right, next one, to find the value of x. To find the value of x, what we're going to do is we need to figure out what these all add up to. To figure out what they all add to, we use the equations we were using earlier. So 180 equals 5 minus 2, because it's 5-sided. So I know each one should be 180 times 3, 540. Once I figure out the total is 540, then I do 540 equals, and I'm going to add each angle I see. So 4x plus 19 plus 122 plus 9x minus 8 plus 7x minus 3 plus, remember this box means 90. All right, you combine like terms and do a little algebra to figure out the answer. In this one, since they're all the same, I know all these are 21 minus 33, 21x minus 33. And since it's 8-sided shape, I can figure out that each angle must be 180, 8 minus 2 over 8. That ends up being 3/4, so 135. So I know each angle here should be 135. So I just do 135 equals 21x minus 33. Do a little bit of math, you'll get your answer. This, don't worry. I guess the only thing to know is that how we use it in mathematics, but this would be like, this is not going to be on the final in that kind of form. It would be in the final in this kind of form, where you're actually using the rules. So for this one, if CE is 6x minus 1 and EB is 2x plus 11, what's CB? So in this scenario, I would need to figure out what's the relationship between this. A diagonal in a parallelogram is always bisected, so they're always equal to each other. So I do 6x minus 1 equals 2x plus 11. A little bit of algebra, you're going to get 4x equals 12, x equals 3. Now, while that's useful, we need to find CB. So we got to take that and plug it in. Since CB is the whole length, I could just plug it into one of them. I'll plug it into CE. 6 times 3 minus 1. 18 minus 3 is 17. And because it's 17, I times it by 2 because I know they're the same size. If you don't believe that, you can also just plug it into this one. 3 times 2 is 6. 6 plus 11 is 17. And then add it together. Anyway, your final answer should be 34 in that case. All right, this one. If angle ACB, so ACD, so this angle right here, is 7x minus 12, and this angle, BDC, so BDC, this angle over here, is 10x plus 5, what's x? In this case, two consecutive angles in a parallelogram are supplementary. Diagonally, as a reminder, diagonally, like C and B would be congruent. But when they're sharing the same line, or what we call consecutive, they're supplementary. So in this case, I would do 7x minus 12 plus 10x minus plus 5 equals 180. After that, do a little algebra. Number 11, this is a rectangle. If PR, so this line over here, is 3x plus 5, and SQ, so this line over here, is 5x minus 9, find TR. So we're aiming for this little guy right here. So in this case, what we know is because of a parallelogram, this should be equal and this should be equal. But because it's a rectangle, I know the whole line PR should equal the whole line SQ. So I do 3x plus 5 equals 5x minus 9. We're looking for TR, so finding x is not enough. So a little bit of algebra. 2x equals 14. X equals 7. With x equaling 7, I just want TR. So if I found PR, which is 3 times 7 plus 5, 21 plus 5 is 26, TR would be half of that. So 26 divided by 2 ends up being 13. So 13 would be my final answer. Please be careful. I probably would put 26 as one of the answers if you forget to cut it in half. That's one of your fake answers in multiple choice. If I gave you this question. All right, this one. If PSQ, so this little angle here, is 6x minus 13, and PQS, so this angle over here, is 5 plus x, find PQS. Okay, so in this scenario, we kind of mentioned it in the past, that Q and S in a total would be equal. But the trick here is I'm not talking about the whole angle S or the whole angle Q. All I'm talking about is the little part here and the little part here. So how do I do that? Well, because it's parallelogram, this one over here and this one over here that I just marked RQS is alternate interior angles. And because they're alternate interior angles, they're congruent. Because I know they're congruent, now I can put them next to each other. Why is that even useful? Well, because it's a rectangle, I know the corner of a rectangle is 90 degrees. So what I can do is, because these two pieces add up to 90, or are complementary, I can set up these two equations together. 90 equals 6x minus 13 plus x plus 5. No need for a parentheses there. Plus x plus 5. From there, you could figure out the answer and then plug it in for PQS. For this one is a rhombus. If NK, so this line is 7, and KL KL. KL, this line over here, is 15. Find NL. So find this line. Now this is a funny one. You need to know that a rhombus in the middle is 90 degrees, while a rectangle, the sides are 90 degrees. In a rhombus, the middles is 90 degrees. So once I see it's a 90-degree triangle, I can make a 90-degree triangle. So there's a right angle. If I know this is 7 and this is 15, I have to do a little Pythagorean theorem for find x. So 7 squared plus x squared equals 15 squared. You can do the math. Next one. If JMK, so JMK, angle JMK, so this angle over here, is AX minus 13, and LMK, so this angle over here, is 4x plus 19, find x. Now, another special fact about rhombuses is that the angle, if a diagonal bisects it, these two angles are congruent. They're cut in half. So the angle is bisected, which means I know the blue and the red is equal to each other. If I know the blue and the red is equal to each other, algebraically I can set it equal to each other. So 8x minus 13 equals 4x plus 19. You can do the algebra to figure that out. This is a square. Remember, a square is just a rhombus and a rectangle at the same time. If ZY is 20, find WV. WV, we're looking for this guy. Let me use green. We're looking for this guy. Okay, if that's so, in this scenario, I also know, because it's a square, that WC is 20 and that this is a right angle. So I find a right angle here where this is 20, 20x. So we need to find this one. So it's going to be 20 squared plus 20 squared plus x squared, or equals x squared, I apologize. You could do the algebra there. If you want, you could actually cheap it a little bit. This is a 45, 45, 90 triangle. I know it's going to be 20 root 3, or 20 root 2 equals x. Equals x. And then divided by 10, this would be 10 root 2. Okay? But if you type in 10 root 2, it might, I think in the answer sheet, they probably write 10 root 2. If you type 10 root 2 into your calculator and you do this in your calculator, check if the decimals match. If the decimals match, then you got it right. But the reason to do 10 root 2 is because this is the 30, 60, or the 45, 45, 90 triangle. You're not forced to know that for this test, so don't worry about that. All right, next one. If WYX, so this angle over here, is 13 minus 7, find x. All right, because it's part rectangle, I know this is 90 degrees. And because it's part rhombus, I know this angle matches this angle. They're congruent, they're being bisected. Which means I know it's 13x minus 7 must equal half of 90 degrees, or 45. Good. All right. Again, I'm not really care about the rules. Just know that parallel sides here, these are considered the bases, okay? So base 1, base 2. So is that just like facts? Yeah, that's just facts, okay? In a isosceles trapezoid, that just means these sides are equal, the diagonals are equal. And one last thing, for a isosceles triangle or isosceles trapezoid, these two are supplementary. They add up to 180. While these two, the base angles, are congruent to each other. And again, that only happens in an isosceles trapezoid. You only consume that in an isosceles trapezoid. Now, we have an isosceles trapezoid. For in this case, CDEF is 17 and 18. If CE is 9x minus 22, so CE is 9x minus 22, this line over here, And FD, which is this line over here, is 4x plus 3. Find CE. In this case, because of the isosceles trapezoid, they're equal to each other. So 9x minus 22 equals 4x plus 3. You could do the math. In this scenario, angle FCD, so this whole angle over here, is 8x minus 1. And angle EDC, so this whole angle over here, is 3x plus 39. Find DEF. So DEF is find this angle over here. Okay? Because these two are base angles, they share the same base, they are congruent to each other. So I would do 8x minus 1 equals 3x plus 39. So now I'm going to just find it because it's relevant for the DEF. 5x equals 40, x equals 8. So x equals 8. I could plug it into either one because they're the same. 8 times 8, 36, or 8 times 8 minus 1, 64 minus 1 is 63. So I know this angle is 63. I know this angle is 63. Now the relationship between these two angles is they're supplementary. So if I know this is 63, then I should know that this should be whatever you need to add to 180. So 180 minus 63, your final answer should be 117. So your answer here is 117. Yeah. VW. The VW is in the middle. A mid-segment is the average of the top and the bottom base. So what do I mean by that? Since it's the average, I add them up, x minus 3 plus 41, and then divided by 2. So x minus 3 plus 41 divided by 2, that ends up equaling 3x minus 21. From there, you do a little algebra. I'll just tell you the first step should be times 2 on both sides to get rid of the 2 on the bottom, okay? But after that, it's just algebra. Now, quadrilateral and chordal planes. We talked about this in class in the post-volume test. So this is what we've learned after the last test. The thing is, looking at these more in detail, these suck. I don't like these. I don't like these, so you could cross those out. Let me go back to it. You can cross those out. And you could cross from 1 to 12, go to 1 to, until we talk about perimeter and stuff. So let's say 1 through 6. Okay. So in this case, just go through 1 to 6, so stop here. But I still want to talk about it. So coordinate geometry, here's a separate section. Coordinate geometry, we're going to prove parallelograms through coordinates. We're going to do transformations. The two transformations we're doing is translation and reflection. And we'll talk about that. First one, we're going to prove coordinate geometry by, or prove it's a parallelogram, okay? If I say A, B, C, D, always know it goes in a circular motion, so it should be like A, B, C, D. Even you start here, it would be A, B, C, D. All right, parallelograms have two rules, or have a couple of rules. One is the opposite sides are congruent. So if I can prove the opposite sides are congruent, then I know it's a parallelogram. The best way to show how long a line is by using the distance formula. So in this case, if I'm looking for AB, I'm going to use the distance formula. So the distance formula, I will not be giving you the distance formula, so either know it or just remember Pythagorean theorem. x2 minus x1 squared plus y2 minus y1 squared. Okay, all under a square root. Remember, I'm just checking if these are equal. So I don't really care what that final answer is. I just care that it's equal to DC or CD. So in this case, when I plug it in, when I say x2, x1, it doesn't matter which one you call x2 and x1. I'm going to read it in order. So I'm going to read it, it's going to be square root. -7 minus 1, because those are my x's, squared, plus my y's, 4 minus 2 squared. If we simplify that, 4 minus 2 squared. This case, negative 7 minus 1 is negative 8. So negative 8 squared is 64. And then 4 minus 2 is 2 squared. So 2 squared is 4. So I end up with square root 68 inside. Okay. Now you're like, oh, is that good enough? No. We have to now check the next pairing, which is C and D. So we're seeing if CD is going to be matching this. So CD, 9 minus 1 squared plus negative 8 minus 6. Negative 8 minus negative 6, because it's minus negative 6, that's a double negative, so it's positive. So this is 8 squared plus negative 2 squared, which again is 64 plus 4, which is 68. Now, is that enough work to show that it's a parallelogram? No. All we proved is that these are equal. We also need to prove that these are equal to each other in order to say it's a parallelogram. So in order to do that, I have to do AD and BC. So AD is square root x and x, negative 7 minus 1 squared, plus y minus y. So 4 minus negative 6, so that's plus 6 squared. That ends up being 8 squared is 64. 10 squared is 100. So 64 plus 100, 164. Again, I don't really care about the actual distance. Now I have to do BC. So BC, because that's the ones that are across from each other. So that's going to be 1 minus 9 squared plus 2, double negative is positive, 8 squared. Again, that's going to be negative 8, so 64, plus that's going to be 10, 100. That's 164. So we figured out these match, and we figured out these match, so we could confirm that it's a parallelogram. We did this by the distance formula. Another way you could do it is by using slope, because if I prove these are parallel to each other, and these are parallel to each other, then I know these two are a parallelogram. Remember, slope is y2 minus y1 over x2 minus x1. Very important here compared to here. If you mess up which one was y2, y1, no big deal. In this case, you just have to make sure you're consistent. So if I were to do AB again, if I'm going to say negative 7 is my x2 or y2 or whatever it might be, I just have to be consistent. So if I'm using A first, it's going to be 4 on top because that's the y, and negative 7 on bottom. And then to B, so this will be for AB. I guess let me do it in a separate color, or the color I used to do it. So for AB, it's going to be 4 over negative 7. And then B is 1 comma 2, so minus 2, because that's the y value, minus 1, because that's the x value. That's going to be 2 over negative 8, or negative 1/4. For CD, it's going to be, and basically, I'm going to just basically copy these things to make it faster for me. On your test, you get to choose, do you want to do this way or this way? You don't have to do both ways. So it's going to be negative 8 plus 6 over 9 minus 1, which is negative 3, or negative 2 over 8, which reduces to negative 1/4. So they match. We know we did it correctly. So we proved that these two are parallel. We need to prove AD and BC is parallel. So AD equals 4 plus 6 over negative 7 minus 1. So that's going to be 10 over negative 8, which reduces to negative 5 over 4. And then this one, BC equals 2 plus 8 over 1 minus 9, which is 10 over negative 8, which is exactly the same thing, so negative 5 over 4. Okay. So you have a choice again on your test to choose either by distance formula or by slope. I imagine most people will pick slope because it just seems a little easier, but it's up to you. All right, transformations like translations. So on the test, I either will give you this where I say in a coded word, like here, I give you original picture, by the way, and then I say either do x plus 5, y plus 2, and describe the transformation, or I'll give you it in words. So in this case, this is going to go right 5, up 2. So in this situation, when you go right 5, up 2, I might give you just the words and the picture, and then you give me the new picture. So how does that even look like? What's the process of that? First off, I need the pre-image. So the pre-image is this picture over here. So we want to figure out what this is. So I'm going to do from here, I'm counting 1, 2, 3, 4, 5, 6, 7, 8. I went 8 left, so that's negative 8. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 up. So my A value is at negative 8, 8. My B value is negative 8 again, and I go up 1, 2, 3. That's up 3. And my C value, which is at 1, 2, 3, 4, negative 4, and then up 3. So that's up 3. Okay. So if I were to follow these instructions, whether it's written like this or written like this, I know I'm moving right 5 up 2. When I'm moving right 5, that means I'm adding 5 to the x. So I'm just adding 5 here and adding 2 here to each one. So in this case, this would be negative 3, 10. This is going to be negative 3, 5. And this is going to be positive 1, 5. After I have this, I am just graphing it. So negative 3, 1, 2, 3, 10, up 10. That's A. A prime, we call it, or A dash, or A whatever. Negative 3, 5, 1, 2, 3, 4, 5. B prime. And C prime, 1, up 5. C prime. If you connect the dots, it should be a congruent triangle to the previous one. Okay? So here, looks like I literally took this triangle right here and moved it up 5. Now, did I miscount? 1, 2, 3, 4, 1, 2, 3, 4. No, I just drew crappy. But whatever. So, it moved it up right 5, up 2. Okay? That's what transformations are, basically. All right. That's a translation, I should say. So that either I give you it in words or I give you an image. So you just make your points, graph your points, and draw the new picture. All right. Reflection. So reflection is kind of like a flipped situation. So first, let's figure out our things. So I'm either going to tell you to reflect over the x-axis or the y-axis. So let's make sure we know both. So let's get our originals. This is going to be 1, 2, 3 to the right. 1, 2, 3, 4, 5, 6, 7, 8. So that's 3, 8, 3, 3, and then 4, 5, 6, 7, 7, 3. All right, when I reflect over the x-axis, so I'm reflecting over here, that means everything's going to go over here. It's going to get flipped, right? Because it's getting flipped, it looks like my y values are the things that are changing. So when I reflect over the x-axis, I flip my y value. So that means this is going to become 3 comma negative 8, 3 comma negative 3, and 7 comma negative 3. So my y values are the things that changed. My y values are the thing that change when I reflect over the x-axis. And that should make sense because I'm flipping over the x-axis, I'm moving up and down. So this should be the y values that change. 3, this is b prime, 4, 5, 6, 7, 8, a prime, and then this one, 1, 2, 3, c prime. And you can see your triangle's nice and flipped over here. Okay? This one, reflection over the y-axis. When I'm doing it from the y-axis, that would mean my x is getting flipped over, right? Because I'm going over the x-axis. So my x is flipped, or flip x. So from the pre-image, so it's going to be negative 3 comma 8, negative 3 comma 3, and negative 7 comma 3. So let's go to B. 1, 2, 3. This will be B prime. 1, 2, 3. This is A prime. And then this is 7, 4, 5, 6, 7. C prime. I'm not going over how to graph a point. You should know that confidently. But either here, you see it kind of looks like it flipped over the y-axis in that case. Okay? So if I reflect over the x-axis, I'm flipping y. If I'm flipping over the y-axis, I'm flipping x. Okay? I know it's not intuitive, like that doesn't make sense straight up, but you know that's how it is. All right. As I said, ignore the stuff on this page about any points. Just focus on what I just taught you. Those are how the questions will look. All right, on to circles. Let's call the circles. Okay. So on to circles. This topic here, arcs and circles. Here is just a reminder of all the things. I'm going to try to explain it quickly in English, basically, for you guys. If your angle over here is 30 degrees, your arc angle is 30 degrees. If your inscribed angle is 30 degrees, this is going to be doubled. So this should be 60 degrees. If you have an inscribed quadrilateral, these two opposite angles is supplementary, so add up to 180. And these two opposite angles, B and D, should equal to 180. They're supplementary. For this one, this and this, if I'm talking about angle 1, if you notice this opening left and right, the angle in the middle that happens not to be in the center, if it was in the center, it would be equal, is going to be the average of the big two arcs that you have here. So AD plus BC divided by 2. They do times a half, but divided by 2 is the same thing. In this case, when you have an angle on the outside, it is big angle, so the one farther away, minus the small angle. So big, CE, minus small, BD. Same thing here. Big, small, BD, minus the small over here, BC. Again, big, so BDC, minus the small, BC. For this one, find JK. If I want to find this arc JK, I know this is a central arc because I have the little dot there. So if this is 152, I can figure out that this angle, because they're linear, is 38, which means this is also 38. And I know this is 38 because 38 plus 152 is 180, and this makes a straight line. This one over here, find YZU. YZU. So I want this angle here, okay? So I know this should equal to each other. this YZU part and this arc. But I don't know what this arc is. It's just 10x plus 9. From information I have, if this is 90 degrees, I know this is 90 degrees. This is 34 because he just straight up told me. And this is 6x minus 13. So I know that all circles add up to 360. So I could do 360 equals 90 plus 34 plus 6x minus 13 plus 10x plus 9. I'm adding all the pieces of the circle to figure out what x is. After you figure out what x is, you plug it in back here. Find arc BC. So in this case, BC is this arc here. If I know this is 29 and it's at the edge of a circle, then I know this arc over here, this is 29, this should be doubled. So this is going to be 58. Because this line is going through the center, I know this is half a circle right here. Since this is half a circle is 180. So 180 minus 58 will give me 122. So your answer for this one is 122. In this one, your edge of angle over here is always half of the big angle. So to make it work, I double the smaller one. So I'm going to do 2 times 8x minus 5 equals 18x minus 28. So I'm multiplying this bottom one by 2 because remember, it's half the size as this big arc. So I have to double it to make it match. You could do the math however, divide by 2 first or distribute the 2. It doesn't matter to me. This one, find W and V. W is supplementary to Y. So if this is 55, 180 minus 55 equals 125. That's W. And then here, these are supplementary. So 180 minus 87 equals 93. And that's V. Remember, they're supplementary to the opposite angles. If angle B is 14x minus 21 and angle D is 4x plus 3, what solve for x? So in this scenario, I did 14x minus 21 because they're opposite of each other. I know they're supplementary. Plus 4x plus 3 equals 180. You do the math from there. This one. Remember, if you have an angle like here, this is the average. So this is the average. I'm looking for M and J. So I'm looking for this guy particularly. Doesn't matter if I look for this guy or this guy. They're vertical, so they're equal to each other. So I'm getting the average of these two angles. So 114 plus 38 divided by 2. That would be whatever my answer is. In this situation, I want FE, so I want this guy. The problem is, I don't have all the pieces of the arc, otherwise I would just subtract it from 360. But I do have that the fact that this is 68, I should know that this part over here should be 180 minus 68, 112. So I know this little angle over here, whether it's CD, CGD, or FGE, doesn't matter, this is also 112. And because I know this is 112, and in between the two arcs, this 112 is the solution to the average of the two arcs. So 87 plus, I don't know what this is, so I'll call it x, over 2 equals 112. You set it up like that, solve the answer. This one, EFG. So EFG, I'm looking for this little angle right here. Because there's an angle on the outside, I subtract. When I'm an angle on the outside, I subtract. Big angle, or big arc, 65. That's the far right one. Minus the small one, 27. Over 2. You plugged it in, solve it. This one, a little bit different. I have the outside angle. I'm looking for the big arc. So I just do algebra. X minus 67, big minus small, divided by 2. I know it results in 53. Remember, when you do a little fraction, you could just times it by 2 on both sides to get rid of the bottom and make your life easier. This one, same issue. I'm just looking for the small arc this time. So 153 minus x over 2 equals 52. Same concept. Over here, you think, wait a second, usually they gave me 2 points of data, right? Now they only give me 1 point of data. What am I supposed to do? Well, there's only 2 parts, the small part and the big part, which means I know the 2 parts together should add up to 360. If that's so, I know the small part is going to be 298 minus 360 because it's a full circle. So it's going to be 62. And once I figure out that 62, I could do what I did in number 9. 298 minus 62 over 2. Again, I'm just setting it up for you. All right, this one, if EB, so this guy over here, is 4x plus 1, and DF, this guy over here, is 12x plus 11, and DCF, so this little angle in between is 9x minus 1, find DCF. So in this case, remember, it's the average of these two, x, y, z. So in this case, x and y, is that z is the average of the 2 outside arcs. So in this case, 4x plus 1 plus 12x plus 11, all divided by 2, equals 9x minus 1. Do quite a bit of algebra, find x, and then just plug it in back here to get your DCF. If a line is tangent to a circle, it forms a right angle. That's what you need to know about it. Also, if they both hit the same point, then you know these 2 pieces are equal if they're both tangent. Okay? And then from these rules, it was just piece times piece gives you the other piece times the other piece. So A times B gives you C times D. And when you have things on the outside of the circle, though, it's going to be outside, so A, and the outside, C over here, times the whole thing. So it becomes A plus B or C plus D. Same rule. Outside, so that's B, times the whole thing, B plus C. In this case, the A is both the outside and the whole thing. So it's A times A or A squared. That's why it's like that. So this one, if PR is tangent, that must mean it's a right angle. Then QS is 7. If this is 7, that makes this whole thing 14. So QP is 4, or QP is 14, because this is also 7. It's a radius. And QR is 16, so this line is 16. Find PR. I hope you notice this is a right triangle. Where this is 14, this is 16, we need this guy. So 14 squared plus x squared equals 16 squared. This one, they're both tangents. Because they're both tangents, they both equal to each other. Because they're both equal to each other, I set them equal to each other. 2x plus 15 equals 7x minus 30. Remember, if you have 2 chords in the line and you're talking about the lines themselves, you do piece times piece. So 14 times 27 equals piece times piece. 21 times x. It's only a little dot times x. Do a little bit of algebra to find that out. Same thing here, doesn't change if it's a little formula. Piece by piece, so 6 times this piece, x minus 4, equals piece by piece, 9 times x minus 6. I would distribute and then solve from there. This one, outside, 9 times the whole thing. In this case, it's 9 plus x. So this is the outside, and that's the whole thing. Times the outside. If this whole thing's 18 and this is 11, this little outside piece which should be 7. Times the whole thing, which they tell us straight up is 18. So outside times whole, outside times whole. Here, outside That's 7 times the whole thing, which is not 2x plus 11, but 2x plus 11 plus the outside part, 7. So don't get tricked by that. Equals the outside, which is 6, times the whole thing, 6 plus 15, which you could do like at one step. You could write 21 if you really wanted to. And then you do solve from there. Here we go. For this one, it's going to be outside, which is 18, times the whole thing, which is 18 plus x, over, equals, I should say, outside, which is 24, times the whole thing, which is 24. So you can just write 24 squared. Find ST. So I'm finding ST, which is, in this case, let's call it Y for now. So in this case, it would be x, the outside, times the whole thing, which is x plus 5, equals 6 times 6, so 6 squared. Now this one causes factoring because I will get x squared plus 5x. You do not need a factor, so don't worry about this question. All right, arc length formula. Arc length formula is, I guess the best way to describe it, if I want the length of just this piece, this is just the edge. If it was a fence, this is just the fence of the field. If this is the fence here, I want to do the circumference. So the circumference times how much my angle is. I like theta, so I'm going to write theta though instead of x degrees. So the circumference times the theta over 360. The reason we do it over 360 is because it's out of 360 is a full circle. So the arc length is the circumference times the theta equals 3 over 360. Since I'm talking about the area now, so if this was a field, we're talking about the grass on the inside, it's going to be the sector area. I'm going to call it SA for sector area. So it's just this little piece here, the pizza slice here, is going to be whatever the area of the circle is. And I guess I should remind you, circumference is pi, 2 pi r. And the area of a circle is pi r squared. So it's the area of the circle times my angle, and this whatever theta or x degrees is, over 360. So just notice if I ask for sector, I should say, or sector area, sometimes I say, you use area. If I ask for the arc length, or the length of the curve or whatever, you use circumference. Otherwise, it's the same formula. So in this case, let's figure out the answer. Here, find the arc length. So I want the circumference. So the length is going to be 2 times pi times r, which is going to be 8, times the angle, 135, over 360. Type that in your calculator, you'll get your answer. In this case, this angle is 316, which makes this angle the leftover after 360. So 360 minus 316 is going to be 44. So this is 44 here. So with that in mind, the little arc length is going to be 2 times pi times my radius, which is 11 in this case, times my theta, which is 44, all over 360. Find a shaded sector. So find the shaded sector. That's going to be the sector area, let's say, is going to be the area in this case, which is pi times r squared, so 19 squared, times my angle, 78 degrees, over 360. If this part is 129, I want the shaded area. So if this is 129, 129 minus 360 is going to be 231. So then my sector area is pi times r squared, so 14 squared, times the angle, 231, divided by 360. All right, equation of a circle. The equation of a circle is this: x minus h squared plus y minus k squared equals r squared. Keep in mind, h and k is the center. So h and k is the center, and r is the radius. So in this situation, they're asking me to identify the center, radius, and diameter of a circle with this equation. So first, let's talk about the center. Remember, in the formula, it is minus h. So because it's minus h, here, your h value is not -1. You're plugging in a 1 to be -1. So it's a flip of the sign. So your center is going to be 1, comma, remember, flip the sign, -4. So the center in that case is 1, comma, -4. The radius, let's go here. The radius is whatever this is, square rooted, because if it's r squared, this is something squared. So r squared equals 81. That means r must equal 9. So my radius equals 9. Since my radius equals 9, my diameter is just 2 times r. So my diameter equals 2 times r, 18. That's all I need to do for that one. Write the equation of the circle below. So first, I want to identify what my center is. My center is, this is the origin, so I went 2 left, so it's -2, comma, I didn't go up and down, so 0. So I could write this part right now. X plus 2, because double negative, plus y squared. Since it's plus 0, I don't need to put -0, so I just write y squared, equals, now I need the radius. From the center, I could count in any of the 4 directions. So I'll just count up. 1, 2, 3, 4, 5. So the radius is 5. If I did it downwards, 1, 2, 3, 4, 5, it should be 5. If I did it right, if I did it left, this should be 5 also. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it doesn't matter. So it's 5. Since my radius is 5, I plug in here 5 squared, or 25. So that should be your answer. Given a point of the circle is at 1, 7, and the center is at -6, -4, write the equation of the circle. So I'm going to use the basic equation here. I have some point, that's x and y, and I have the center, which is h and k. So I'm going to plug in x, y, h, and k to find r squared. So x, which in this case is 1, minus h, which in this case is -6, so plus 6 squared, plus y, which is in this case -7, minus k, which is -4, so that's plus 4, squared. If you notice, it kind of looks like the distance formula, equals r squared. So this is 7 squared plus -3 squared. This is 49 plus 9 is 54, or 58. 58. Because it's 58, and that equals r squared. Now remember, I don't really need the radius, I just need the equation. So I don't need the square root of 58. So I'm just going to write it generically, x plus 6 squared plus y plus 4 squared equals 58. Remember, I don't need the square root for that because I'm just writing the equation. You will not have a question like this. I'm not going to waste my time. Okay. This is just practice of what we just did. Don't worry about this one. Yeah. Let me talk about this one. If EH is 15, what's the approximate length of EG? So this arc here. So this one is like a complicated one. Let's talk about it. If this is 52, then I know this is 104 because it's doubled because this is the edge of the circle, which I know this angle must be 104 because that's the central angle that matches the arc. But I don't want the measurement. I want the length, right? So then that kind of forces me to use the length formula, which is circumference times theta over 360. The circumference is going to be, since I figured out, this is 15, is 2 times pi times 15 times my theta, which I figured out is 104, divided by 360. Whatever that is to solve that kind of question. Again, I'm just going to quickly look through it to see if anything I didn't really do. Okay, so something like this. If this is 54, then I know this is 108 because this is an edge circle. Since I know this is 108 and I know this is the same and this is the same, I could do 108 plus 2x, if I call these both x's, equals 360 and solve from there. Let's see. Oh, this one. Z, I want angle Z, so I'm looking for this guy here. Now, this is the angle that's at the corner of this part right here. So either you can figure out that this whole red part is going to be 360 minus 86 minus 62, because it's minus these two pieces. That gets you some number. And whatever that number is, you can cut it in half. Because this is a corner, this is an angle at the corner, you could cut it in half to get your answer. Okay. Let's see. 5, you've done that. 6, we've done that. 7, we've done that. The setup for this one, though, this is 251. So I know this is the leftover circle because there's only two parts of the circle. So this should be 360 minus 251, 109. And then this is 9x plus 26. So 251 plus 109. I'm sorry, minus 109. Minus 109 divided by 2 equals 9x plus 26. Don't worry about this. All right. What do we got next? Okay. Area. I'm not going to give you a compound area. Don't sweat it. Oh, okay. So, volume and surface area. So, let's go through it quickly, okay? You have your formula sheets. It's the same formula sheet. I'll post it along with this video as the one I gave you on the test last time with the pictures. This is a rectangular prism. So the volume for the rectangular prism is length times width times height. You cannot mess this up. If you do mess this up, I will bully you. I will insult you. It's 12 times 10 times 19. Does not matter which one you call length or width or height. The surface area for a rectangular prism is 2 length width plus 2 length height plus 2 width height. Again, it does not matter which one you call length, width, or height. So 2 times 12 times 10 plus 2 times 12 times 19 plus 2 times 10 times 19. At the end of the day, you just plug that in and solve. All right, this one. This is a triangular prism. So the volume, it's a prism, is going to be the capital B base times the 3D height. Maybe I should use capital H for 3D height. So the capital B base, because it's a triangle, is 1/2 base times height. Little base times height, because we're talking about a 2D shape. In this shape here, the right angle is on the left, so I already have what I need. So 22.5 times 14 divided by 2. So 22.5 times 14 divided by 2. That's going to be your capital B base. And then I'm going to times it by my 3D height. The 3D height is the distance from one triangle to the other triangle. In this case, it's 24. So I would times it by 24. Whatever you typed in the calculator, that's what you get for your answer. This one, surface area, it's a prism. So it's two bases. Or usually, I guess we do it this way. Surface area is the lateral height plus 2 times base. We already did the base, which is this red one here. So I'll rewrite it when we get there. But the lateral area is the 3D height. I'll use a capital H for that. So the 3D height times its perimeter of the base. So the perimeter is the edge of the shape. In this case, the edges is 22.5 plus 14 plus 26.5. So in this case, it is going to be the 3D height, which we already figured out is 24, times the perimeter, which is the sum of these three things, which is, I guess I'll just write it, 22.5 plus 14 plus 26.5. So we add that up. And then we're going to add that to 2 times base. So 2 times the base, which we found earlier, is over here. So I'm just going to rewrite it as 22.5 times 14 over 2. It's still a triangle base, so it's still that kind of base. All right, type that in your calculator, you got your answer. This one is a cylinder. A cylinder is a prism. So cyl volume equals base times height. The volume equals the base. In this case, if this whole thing is 16, then the radius is 8. The area for a circle is pi r squared. So pi times 8 squared times the 3D height, which in this case is 22, because this is the distance from one circle to the other circle. Type it in the calculator, you'll get your answer. Surface area, lateral area, plus 2b. So the lateral area is the hypotenuse, hypotenuse. It's the 3D height times the perimeter. So the 3D height is 22. The perimeter is the circumference. A circumference is the perimeter of a circle. So that's 2 pi r. So 2 times pi times 8. Plus 2 times the base, which we found out over here, is pi times 8 squared. Type that in your calculator, you get your answer. This one, volume. This is going to be a pyramid. A pyramid volume is 1/3 base times height. So the problem, though, is they give me the slant height. This looks like the height on the edge of the triangle. So I need to figure out the 3D height, so the height in the middle. The best way to do that is to rewrite it as a right triangle. In this case, I know the hypotenuse is 20.8. I know the base here is not 16, but 8. So I need to find this to find the 3D height. In this case, I'm going to actually just check. Actually, I'm just going to check what the answer is, so I don't have to go crazy for it. Why? To figure out what the height is, 19.2. I'm just going to use this to describe it. All right. So in this situation, the height is 19.2. We do that by using a right triangle, where this is 8 and this is 20.8. So we find x. This is my x, or my height. I guess I should use h. So that means it's going to be h squared plus 8 squared equals 20.8 squared. So that's that. This number here is the base. Remember, the base is a square, so that's 16 squared. or 16 times 16. So that's how they got 256. That's their final answer. Oh, they showed the base over here. I am just using this now because I'm tired. So I'm sorry if this is not that helpful, but whatever. So in this case, surface area, again, L times P is the lateral area. So let me just write it as lateral area equals 1/2 LP. So L being the lateral height, so the slant height. So 1/2 times the L, which is 20.8, that's the slant height given in the picture, times 64 is the perimeter. Remember, the perimeter is 16 plus 16 plus 16 plus 16, because you're adding up the sides of the square, plus B, which you already figured out is 256. All right, for this one, the volume, it's a pyramid. So volume is 1/3 base height, capital H height. So in this case, the base is pi r squared. So this is the base. So they gave me the r, which is 5.6, and then the height 3D is 9. So 5.6 squared times 9 gets you this answer. The problem is I need the lateral height for the perimeter. So here is going to be, I guess I did base here, plus LA, in this case, lateral area. And remember, lateral area is 1/2 L times P. So I kind of need L in this case. So you have to make a right triangle again. Let me make it in the same shape. So if this is 9 and this is 5.6, we do a little algebra to figure out this thing, which we figured out over here is 10.6. So perimeter is 10, or I'm sorry, the lateral area is 10.6 here. The perimeter, so they do a little different, but the perimeter, how I would do it, is 2 times pi times 5.6 times 10.6. But remember, because it's a half, you put a half in front. In this case, in this formula, they cross out the half. So that's why they're just left with this part. Okay? You will not need to do a regular triangle. Don't sweat that. Spheres are nice and easy, at least. The volume is 4/3 pi r cubed. It's already written here. So if this is 15, then you know this should be, or if this is 30, this should be 15. 15's cubed is this. Over here, 4 pi r squared. So 4 times pi times 16, or 15 squared. That's just the formula for a surface area of a circle. You don't have to worry about a hemisphere. The quiz review, here's the answers. Again, don't do anything that causes, you don't have to do any like shaded or compound figures like that, okay? Otherwise, that should be your review. Hope this helped. Sorry for the late review. The original one basically was unlistenable because it was so laggy. It sounded like it stopped and paused all the time. So yeah, hopefully you do well in the final. Of course, if you have any questions, ask me in class, send me an email. I'll take care of it. Thank you.